Evolution. It's the non-random selection of random mutations. That sounds a little complicated, but let's break down what that means. At its most basic form, a mutation is a replication error within the genome of an animal that typically is going to affect its phenotype. This happens all of the time. Some mutations, most mutations, are neutral. They don't really do anything. They don't make a notable change. Some mutations are beneficial. This is why a lot of us don't have a problem drinking milk past the age of, I think it's 2. We are able to produce lactase enzymes that help us process that. Some mutations, and this is often what's thought of as default when people hear mutation, are deleterious. This would affect their fitness in the wild. So, if you were to look at Charlotte here, she is a wild-type African house snake. These guys have very muted dark colors. This would help them to blend into their environment and evade predators. But if we were to look at Sweb here, she's an albino African house snake. In the wild, she would stick out like a sore thumb, and a predator would have no problem at all finding her and eating her, thus removing her from the gene pool and preventing that trait from spreading throughout the population. That would be the selection pressure. Fortunately, she knows how to utilize disguises to blend in. Albinism's a funny one, though. It's a recessive trait, so both parents need to be a carrier of the trait in order to produce a phenotypic albino offspring. So if you are born of an albino and you would look like a wild type, that would be kind of a passive, a mutation that is present in your genotype that isn't affecting your phenotype in a deleterious way. But if you were to then breed with an albino or another individual's head albino, you might produce albino children. Those ones wouldn't blend in so well. So why then would you intentionally breed for these mutations that could be deleterious? Well, we talked about selection pressures. Those are present in the wild. In captivity as pets, there are selection pressures as well. For example, animals that start off, they hatch out, they're not good at eating, they never establish very well, and even though you might get them eating, those traits might carry on to their offspring. Those gene pools over time are going, or those genes over time are going to become eliminated from the gene pool because you don't have as much success breeding them as you do ones that are happy to eat right away. But things like color mutations and pattern morphs, well, there's no predators inside of a terrarium in your living room that's going to eat your pets, hopefully. And so those mutations would no longer be considered deleterious. For another example, let's take a look at some of our sand boas. This is Mr. Tremors. Well, actually, this is just dirt. But within the dirt is Mr. Tremors, and he is a little Kenyan sand boa. Now, they do have this bright orange patterning on their back, but they spend most of their time under the ground with just little bits poking up. So that pattern just helps break up their shape a little bit, helps them blend in really well. However, close. If we look at Mr. Gozo, Gozo is an albino Kenyan sand boa. And now if any part of him is sticking out of the dirt, he sticks out like a sore thumb because he's bright yellow and orange. However, not every morph mutation is going to be deleterious even outside of the pet trade. This is an anetheristic, there he is, anery sand boa, also a granite, I think. So this is still a snake that's going to blend in super well to its environment. So it's not to say that you will never find morph snakes in the wild. They do pop up. Typically they have colors and patterns that are conducive to survival within those environments. And the fun part about those mutations is that they are stackable. For example, this is an albino, but it's also anetheristic. But it's also genetic stripe, but it's also paradox. This has a whole bunch of mutations going on. If it were out in the wild, it wouldn't last very long. But as a pet that we're taking care of, he's going to do just fine. But that doesn't mean you can just start stacking mutations willy-nilly without knowing what you're signing up for. This little guy, for example, is a spider ball python. And these guys are a little tricky. They've got a little fusion kind of thing going on with their eardrum bone. Well, in snakes it's a little different. It kind of connects to their jawbone so that they can pick up on vibrations and really low frequency noises. Either way, on these guys it ain't quite built right. So they have a little bit of a head wobble, and they can miss their food sometimes. Usually they do okay, but they don't tend to do quite as well as most other ball pythons. So even within a captive bred setting, this would be considered a deleterious mutation. And you have to be careful what you would breed this to, especially if you were to breed it to another spider or a champagne. Some traits just don't mix well, and 2 copies of spider in a baby snake isn't even going to come out of the egg properly. And it's not just spider. Some of the more desirable ball python traits have issues as well. If you were to breed black pastel to black pastel, you get a pure black ball python. That's pretty neat. However, you're going to have a high rate of birth defects. These are called shark jaw, where their bottom jaw is underdeveloped. These snakes will tend to not eat very well. And so you got to really be careful what you're pairing up. You might see a look on an animal that you like, but it might not be the most responsible to breed said animal. And not every wild type snake is going to have drab coloration either. These Madagascar hognoses have some pretty nice yellows on them, and they stick out like a sore thumb to us, but you got to remember the things that would be eating these animals in the wild, they might perceive things differently than we do. Maybe they see UV light, maybe they see infrared, both things that we can't see. So this snake, under the perception of a predatory bird, is going to look a lot different than it does to us, and it's probably going to blend into its environment super well. And then you also have Batesian mimics, things like milk snakes. They're going to try to look like coral snakes, bright red. They want to stick out because they want predators to think that they're toxic. And the moral of this is that mutation isn't bad. Mutation isn't scary. Mutation just is. It's a thing that exists. And you can select for it. You can select against certain mutations just to get the desired result you're looking for. You might scoff at it, but if you've ever had corn, or honestly anything from the produce section, you've had a genetically modified organism. That doesn't mean that they grow it in a petri dish. It just means that they're selecting for the biggest, tastiest strawberries.